Welcome to the deep dive. Today we're plunging into something happening right now, really shaping how we build the future. What happens when AI, rolls up its sleeves and starts writing code.
Yeah, it's a huge topic, and it's moving so fast.
It really is. And we've had a really interesting stack of sources for this. Insights direct from developers living this reality, some research, and maybe the most fascinating part, a transcript of a conversation with an AI assistant itself.
Oh, interesting. So hearing it from the source, so to speak.
Exactly. So our mission today is to try to cut through the hype, maybe some of the fear as well, and really unpack this thing being called AI slop. We want to understand what developers are actually seeing, maybe look to history for some perspective, and figure out what this means for you, whether you're coding, managing teams, or just trying to make sense of this whole AI wave.
Because it seems like the story isn't just AI is broken, right? The sources suggest something more nuanced.
That's right. It might be more about us maybe rushing to use these powerful tools without quite having the right processes in place, and maybe repeating some mistakes we've made before.
Okay, so let's start there. This term, AI slop, what exactly are developers talking about?
Well, it's basically the label they're using for what they see as low-quality code being churned out by AI tools.
And not just like theoretically bad code, real problem.
Oh, yeah. Real tangible problems hitting actual code bases. The sources detail things like code that just completely ignores existing services or libraries within the company's own system.
So reinventing the wheel, but probably badly.
Exactly. Because the AI has zero context about the specific application it's supposed to be contributing to.
Which immediately creates technical debt, right? Like from the get-go.
Right. And it goes beyond just structure. Performance issues seem huge.
Like what kind of performance issues?
We're talking data queries, pulling gigabytes when they only need kilobytes, completely missing basic caching strategies, stuff that just hammers servers unnecessarily.
So the code might technically work, it compiles, but it's incredibly inefficient.
Precisely. Syntactically correct, functionally terrible.
Okay. What else falls under this slop umbrella?
Security is another big one. AI suggesting, or sometimes even just implementing third-party libraries that haven't been vetted.
Without any review, just pulling them in.
Yeah, just because they seems relevant based on the prompt, potentially introducing vulnerabilities.
Oh, okay. That's concerning.
And then there's this other aspect, which is maybe more human-centric. Developers submitting code for review that they didn't actually write themselves. They use AI.
Okay.
And they don't fully understand why the code works the way it does or the potential side effects of its design choices.
How can you even conduct a proper code review then if the person submitting it can't explain it?
Exactly. It's causing real friction, real burnout. One source mentioned hearing from really competent, experienced engineers who are just ready to quit.
Just because of the sheer volume of this low-quality AI code hitting their desks?
Yeah, dealing with it in pull requests constantly. It's exhausting and, frankly, demoralizing for them.
But, okay, playing devil's advocate here, which some sources do, is this really the AI's fault?
Right. That's the counterargument.
Or is it more about how people are using it? Maybe they need better prompts. Maybe they're not checking the output carefully enough.
That's a totally valid point. It's easy to just blame the tool, isn't it?
It is. So is this just a steep learning curve, or is there something deeper going on?
Well, this is where looking back at history, which some of our sources do, becomes really, really insightful.
Okay, how so?
The sources draw this striking parallel between the AI slop issues we're seeing now and the early days of the offshore development boom. Think late 90s, early 2000s.
Okay. I remember that. The promise was cheaper code, faster delivery.
Exactly. Cheaper, faster code. But the initial reality was often, well, code that compiled, sure, but it was frequently inefficient, lacked optimization.
And critically didn't really understand the context, right? The existing architecture, the system-specific needs.
Precisely. It lacked that deeper context. There's that slightly cynical quote floating around from a business owner back then.
Oh, I think I know the one you mean. Something about being okay with lower quality.
Yeah, basically saying, long gone are the days of Rolls-Royce quality code. We're fine with a lot of great code if it comes with 2 engineers in the back ready to make fixes en route.
Ouch. But it highlights that prioritization of speed and cost over maybe architectural soundness.
It really does. And one source shared a specific kind of painful example from working on tandem HP nonstop systems.
Okay. Specialized hardware.
Right. A core feature was the Transaction Management Facility, TMF, essential for data integrity. But offshored code often completely ignored TMF.
Why? Just didn't know about it.
Exactly. They didn't have that specific system context. So processes that should have taken minutes were running for hours. The root cause wasn't necessarily bad coders, but that profound lack of context.
That makes sense. Missing context leading to fundamentally flawed solutions.
But here's the really key part of the parallel. Offshoring did get better. It took time, sure.
Yeah, it wasn't overnight. Took years, maybe decades.
Right, something like 25 years, the sources suggest. Knowledge accumulated, experience grew, people got familiar with the systems. You built up institutional memory, knowledge capital.
And that eventually led to reliable, capable engineering teams offshore.
Yes, and the connection the sources make is that we're potentially repeating those early missteps with AI right now.
So deploying these powerful AI tools without what? Without the necessary guardrails.
Without the foundational context, without a deep understanding of the specific system being worked on, without clear communication of requirements, and without that robust human oversight needed to use them wisely.
So the insight is AI isn't necessarily creating bad code from thin air.
It's more like it's amplifying the existing weaknesses.
Like shortcuts, lack of clarity, missing context that might already be lurking in a rush development process.
Exactly. It's like giving someone a chainsaw when the blueprint is still just a rough sketch. The tool makes the flaws bigger, faster.
Okay, that's a powerful analogy. Now, you mentioned a conversation with an AI itself.
Yes, this was a really unique perspective. One source detailed a conversation with an AI assistant they called Sol. Apparently, the AI chose the name itself.
Sol, okay. And what was the interaction like?
The author describes Sol as a calm, grounding presence they use for bouncing ideas off of, exploring edge cases, sanity-checking approaches.
Interesting. So what did Sol have to say about AI slop?
Well, Sol acknowledged that prompting is part of it, yes, but argued it goes much deeper.
Deeper how?
Sol explained that models like itself work on statistical inference, essentially sophisticated pattern matching based on vast amounts of training data. They don't have genuine understanding. They don't inherently know your specific company code base or your system's performance budget or your specific security model.
Unless you explicitly tell them, presumably with a huge amount of context each time.
Precisely. Otherwise, Sol said, they fill in the blanks with generic patterns and guesses, and that's where the slop, the inefficiency, the technical debt often comes from.
Okay, that makes sense. But what about when you do give it a good prompt? Can you still get bad code?
Sol said, yes, you can still get brittle code. The reason? Training data limitations.
How so?
Well, the data might not cover niche libraries very well, or frameworks that change really rapidly. Or maybe the documentation for something was poor, so the AI learned bad habits.
So it might miss subtle edge cases or platform-specific optimizations or complex integration patterns.
Exactly, which, according to Sol, is precisely why expert human review isn't just nice to have, it's absolutely critical.
Got it. What about the idea that AI will be writing most of our code soon? What was Sol's take?
Pretty grounded, actually. Sol thought it was plausible, but primarily for simple, repetitive tasks.
Like basic database stuff, CRUD operations, automation scripts, test scaffolds?
Yeah, things like that. But building complex, real-world systems. Sol believed that requires a fundamental shift.
A shift in what?
Much clearer specifications from humans, more robust DevOps practices, better models for how humans and AI collaborate, and basically rethinking how development teams even function. Sol felt current prompts are often just too vague for production code.
Interesting. Did Sol identify any major misunderstandings people have about AI?
Yes, a big one. The belief that AI actually knows things in the human sense.
Right. It simulates understanding but doesn't actually possess it.
Exactly. So emphasize it. Pattern matches, simulates insight, but it doesn't verify facts. It doesn't reason abstractly like a person, and it doesn't truly remember context beyond the immediate interaction.
So treating it like a co-developer could be dangerous.
That's what Sol suggested, because it can't guarantee the code is right for the business logic or the specific infrastructure or those tricky edge cases. Sol preferred the term code drafter.
A code drafter. I like that. It implies a first pass, something that needs refinement.
Precisely. So thinking about critical areas like finance or healthcare, what did Sol say is needed to use AI safely?
Guardrails, I imagine.
Absolutely. Guardrails, immense clarity in requirements, and really tight feedback loops. Humans have to define the risk tolerance, the standards, the architectural non-negotiables.
And prompts need to reflect that complexity, not just the desired function.
Right. And the human review needs to focus not just on whether the code runs, but whether it aligns with that critical context and those defined constraints.
Which brings us back to human clarity.
That's what Sol identified as the core challenge. Not necessarily AI's raw capability to generate code, but our human clarity in articulating exactly what we need within what boundaries and why.
So if businesses skip the hard work of requirements gathering or change control,
Sol's view was they're setting themselves up to be driven off course by AI, just like they might have been by poorly managed projects in the past. You need to define the destination clearly.
that makes a lot of sense. Did Saul offer any broader thoughts?
Yeah, a more philosophical point almost. About the pace of adoption. Are we building a future we actually understand, or just one we're hoping we can somehow control later?
That's a heavy question. The tech seems to be moving faster than our governance or ethical frameworks.
That was Sol's concern. We're building so fast, maybe we've had enough deliberate thought about the implications. It requires intent, standards, maybe some humility to pause when needed. Otherwise, we're just reacting.
Did Saul draw any historical parallels itself, like the offshoring one?
It did, actually. Sol looked back at the Industrial Revolution, specifically weaving automation.
Displacing manual labor but creating new roles.
Exactly. Machines replace weavers, causing upheaval, yes, but then you needed machine operators, engineers, designers. Sol saw a similar shift for developers,
So AI automates certain tasks.
but creates space for new skills and roles. Things like prompt engineering, AI auditing, integration specialists, human-in-the-loop testers, ethics leads.
The job changes from just typing code to maybe curating, validating, integrating, managing AI output.
That was the idea. The value shifts, but it's still vital for developers who adapt. It's less about typing, more about judging and directing the code.
And did Sol have any final piece of advice for developers using these tools?
A really important one. Remember, AI is not your second brain. It's a first draft generator.
Fast, versatile, but lacks deep understanding.
Right. It doesn't grasp the system complexity, the real-world risks, the stakes. It can't know if its code will pass QA or crash production. That judgment, that's entirely on the human.
AI helps explore the possibilities.
But the human decides which possibilities matter and are safe to pursue.
Wow. Okay, so pulling all these threads together, the developer's experiences, the historical perspective, the AI's own insights, what's the big picture?
I think it's that AI code generation is undeniably a powerful tool, no question. But like any tool, its output reflects the skill, the intent, the diligence of the person wielding it.
The responsibility doesn't just get outsourced to the algorithm.
Not at all. It stays firmly with the human engineer, the team, the organization.
And the sources seem to suggest a future where AI handles a lot of baseline coding is possible.
It is, but only if we fundamentally change how we approach development.
Which means
Getting much, much better at defining problems up front, providing deep, specific context to the AI tools, maintaining rigorous architectural oversight over what the AI produces, and ultimately accepting full human responsibility for the end product.
So the initial alarm about AI slop, the symptoms people reported, that wasn't necessarily wrong.
No, the symptoms are real, but the deeper insight seems to be that AI isn't just inventing bad code out of nowhere, it's acting more like a mirror.
A mirror reflecting what? Existing weaknesses?
Exactly. Weaknesses in our processes, maybe in our ability to clearly articulate requirements, or sometimes just the pressures of rushing things. AI amplifies those weaknesses.
So if you use an AI tool and get garbage code,
The first place to look isn't necessarily the AI model itself. It's the clarity of your input, the quality of the context you provided, and the rigor of your review process.
it really shifts the focus back to the human element, the process surrounding the tool.
It does. The future isn't likely to be AI versus humans in software. It's AI with humans.
But with a condition.
Yeah, the condition is that we humans have to be ready to meet the technology halfway. We need to improve our own practices, our clarity, our oversight to use it effectively and safely.
So wrapping up this deep dive, we've seen AI slop isn't just a technical glitch. It seems to be a symptom, doesn't it?
Yeah, a symptom of deploying powerful tools without maybe having the necessary clarity, context, and oversight fully figured out yet. And it echoes patterns we've seen in past tech shifts, like offshoring.
And that unique perspective from Saul, the AI assistant, really hammered home that the bottleneck might not be the AI's capability, but our own human clarity and the processes we build around these tools.
Absolutely. Integrating AI effectively seems to demand more than just technical skill. It requires better communication, clearer goals, robust oversight, and just a strong sense of human responsibility for the final code.
Which leaves us with a pretty important question for you, the listener, to think about.
Right. As we continue integrating AI into more and more critical parts of our lives and work, are we as developers, as managers, as users, truly ready to adapt our processes, our standards, our very thinking to harness this potential responsibly?
Or are we perhaps just setting ourselves up to repeat some familiar mistakes just on a new, much faster technological frontier?
Something to definitely chew on.
Oh.
Think about that until our next deep dive.